First they ignore you. Then they make fun of you. Then they fight you. And then you hit publish. Or you do a pull request. Welcome to the desk of Lady Ada.
Thank you, floating goth head of Phil. It's late night. We're just wrapping up a little thing on a weekend night. We need to stay up. But I thought I would give an update, more Circuit Playground hacking. So let's see, it was 2 nights ago that we did the speaker test. And we showed that we also had the capacitive touch stuff working without needing external resistors. So that's all good. And one of the reasons that I wanted to get rid of the extra resistor packs and use the native capacitive touch sensing on the SAMD chip is so I could have some extra space. And I wanted that extra space so I could add IR remote control and receiving. So this is the extra circuitry that I added. This is a IR remote receiver, and it's a 2-in-1. You actually have a separate pin IR diode, and this is read by this chip, the VSOP 838. There's actually a huge series. There's like a 538, 338, 532, whatever. There's a bunch of different kinds. This is a 38 kilohertz amplifier demodulator. It takes the IR signal, boosts it, and then filters it, and then pulls out the 38 kilohertz subcarrier, and then gives you raw data output. And that's going to a pin called remote in. And then also there is an IR transmitter. So this is a high power LED. These can be driven up to an amp at a time for short peaks. A little transistor. I'm just using an MMBT 2020 whatever 2222 standard NPN for now. I can update that later. Then a little resistor just to keep the current limiting the output pin. And so these are connected to 2 pins on the SAMD processor, which is over here. And on the board, the silk screen's kind of messed up because I haven't updated it. But this is the receiver LED here, and this is this is the receiver on the right, and it goes into this chip. This is the receiver chip, and then it has a little, RC filter for the power supply just to keep it nice and quiet. And this is the transmitter, which then you see this trace here goes to a this cathode goes to an NPN transistor here, and this is that resistor. So this is the IR receiving and transmitting section. And so since I got the speaker stuff all working, one thing I realized right after I finished the last show is I've been working on Rev G. And what I did in Rev G is I shifted a couple of wires around. I still have to finish routing. But one thing I did is the speaker lines. Remember I was talking about this Class D amp, and I said, well, the Class D amp has bridge tied load, so that's 2 pins, input, so that's 3 pins, power and ground, that's 5 pins, and I was like, oh, what was the 6th pin? Was it a gain pin? I forgot, it's a shutdown pin. There's a shutdown pin on it. So what I did is, since I'm going to be sharing that analog output, so that people can hook up a stereo or speakers if they don't want to use a little mini speaker, I also connected the shutdown pin, which is this little pin, to one of my extra GPIO. And this means that if you are going to be using the analog output as a pad, like if you want to hook it up with alligator clips to a speaker or headphones or stereo, you can disable the internal speaker just by toggling that pin low. So I thought that was kind of neat. Good use of baths. Baths are where I get some really good ideas because I'm finally relaxing. Go baths. Okay, so that's done, but then I was like, okay, so I got the speaker stuff working, got the capacitive touch stuff working, so I only have a couple more things to do. I have to do IR receive, IR transmit, and then I have to get that PDM microphone filtered. I got it working, but I don't have the audio nicely filtered. I have to do some software filtering. So today I was like, well, let me spend an hour and just play around with IR receiving code for the SAMD. The most popular library that people use for IR receiving with these little remotes is called IR Remote by Ken Sheriff. It's an amazing library. It works really well, except that it hasn't been ported to the SAMD. So I'm going to be looking at that. Another person actually did a bunch of work. I might have to just integrate some of their changes and like update it and then submit a pull request. But while I was waiting, also friend of Adafruit, Chris Young, Cyborg 5, has his own library that does IR, receive and transmit. And he uses a different technique, and so he already ported it to the SAMD processor, which is really cool. And so I'm like, oh yeah, it's a good opportunity for me to test it out. So that's what I did. So here is, let's go to the overhead and I can show off my little test jig. So I always just like testing out just with like, Arduino Zero, just because it's, breadboard, you can modify it. And here's the IR receiver. So this is an all-in-one receiver, and you power these with 3 to 5 volts, power, ground, and then output on another pin, and then there's a little lens here. It has the IR receiving diode and the chip all in one. The problem is that these are very big and they are through hole only, so this is why I didn't use it on the circuit playground. But it is really handy for just testing out. And here's the remote control that we have in the shop. I like this because it has just like a bunch of buttons with like handy generic labels like, up, down, left, right, play, pause. Yeah, this is one I have for my little stereo system at home. This is very similar kind of thing going on here. They're all very similar little remotes. You'll see these all the time. They tend to use the NEC protocol. It's a generic useful protocol, and then you can test them with a inexpensive camera. iPhones have an IR filter, but like this webcam doesn't, so you can see it's sending data. So the next thing we want to do is just get this working here. So let me plug this in. Let's see. Program. Okay, so let's plug that in to my Arduino, and then let's go to the computer. And I'm just going to use the raw receive function that Chris Young wrote. This isn't taking it and decoding the data. It's just saying like, look, did you get anything at all? And this is handy to get started with. And for this one, I connected it up to pin 2. Oh wait, hold on. I got to go back, and I have like 5,000 boards. Just 1 second. I'm going to re-upload it just in case it didn't grab. Was there any questions while I'm doing this IR hacking?
Only of the theoretical kind.
No, that I can't help with. Much compiling. Can't wait till we do CircuitPython tutorials. Less compiling.
Want me to
More running.
Want me to fill the airtime with something?
No,
Okay.
we're ready. Okay, so I'm gonna reset this board, and it's gonna say, okay. Sometimes it gets something just like flickering data, so it's like this is unfiltered. But now when I take my remote and like I press up, it'll get like a really nice chunk of data. So you can see it has just the raw timing, like 55, 605, just up. You can tell that there's like, some, there's like long pauses, like there's like a long pause here of like 1,600, 1,600, and then there's short pauses of about 500. So depending on one button, you'll get different alternations of the long pulses and the short pulses, and that's how the data is transmitted. All of them about 68 pulses long, which is pretty normal, but the actual data is different. And then you'd write a parser that would take this and transform it into like a hex value. So for example, this is 68, but it's really like there's marks and spaces, so when you set those, it turns out to be like basically about like 32 bits. Okay, so the next thing I want to do is I'm going to hook it up to my circuit playground. So let me select the circuit playground, Express, and in the variant file, which is like you can see right here, I've hooked up the IR to be GPIO number 39. So let's change this pin to be 39, and then let's connect it up to my victim circuit playground. And then we'll upload. It's super tangled. Okay. So it's ready to receive, and now do the same thing. And yay, we're getting data. Actually, you know what's funny? When you get this like raw data len 4, that's actually a repeat code. If you hold down a button, you'll get these repeat codes. They go on forever. The first time you press the button, it sends the full signal. If you hold down the button, it sends like a little thing that says, "Oh, just repeat the last thing you got." So it's something you have to watch out when you do IR receiver stuff. So this looks good. I'm actually getting the same basic data, 500s and 1600s. And so far so good. So I'm pretty happy with that. I wasn't worried that the circuit wouldn't work. It's pretty simple, but it's always good to test it. So the question is, how far do I have to be before it stops working? Let's do a little target practice. Looks like it works from about 4 feet away. Not great, but one of that could be this remote might not be that good. And you do have to aim it pretty well. You have to make sure that you're really getting signal. So yeah, about 4 feet. What do you think?
Yeah.
All right. Well, that's not bad. It's, there's a little room for improvement. I would like it if it would work for up to 10 feet away. Problem is that when you're not using a lensed receiver, it is going to be a little tougher. Also, it's a little shadowed. Do you want to go to the overhead? I can show it. So this is the receiver here. It's kind of in the way of the button. I don't know. I guess I can move it around. There's not a lot of spaces to move it into. But I think for now, maybe it's okay. Maybe I'll just be like, look, this isn't something for remote, like really far, like across the room. Maybe this is only good for like circuit playground to circuit playground communication. Or if you have a project and you want to control it and you want to have like more interface buttons than the 2 buttons and the switch on the device, so you can use this to change the LED pattern, or maybe if it's playing a tune, or what demo program it's running. So do you have any ideas for other IR projects you could do with it?
Well, with infrared, one of the projects I'd like to revisit is a little cute owl that chirps out off codes.
Mm-hmm.
So you just put this owl anywhere, and if there's any TVs around, it just turns off the owl.
Okay,
and
so
and the TV.
Like a recorder and remote. That's actually a demo, I think.
Yeah. Also, it could be a parrot that listens and then repeats it out.
Uh-huh. I'm gonna make this so that.
Someone said code war badges that talk to each other.
Yeah, one of the projects that we saw that was pretty cool was that the zombie game.
Yeah.
So we should get maybe 2 of these working. I have another circuit playground over here that I have to get working. It's acting a little funny, but I'll get it working. And then we can try seeing, if you have 2 circuit playgrounds, that's what's most interesting. It's not like getting the remote working, but how far away can 2 circuit playgrounds talk to each other? It'd be neat if they could be maybe 4 or 5 feet away. I think that would be a good distance. Yeah,
the other thing for circuit playground, one of the things we want to do is each one would kind of be individual. So when you first get it, it's running LED code that's a little organic, that's a little bit like a Tamagotchi. Each kid would have a different one, and then maybe if they get close to each other, the R signals would be able to do something so they know they're near each other. So instead of having physical computing, in this case, CircuitPython be a solo thing, which I think long-term makes everyone antisocial jerks, what would happen is the first experience that a lot of young people would have is the more computing you do together, the more fun it is, and it's fun to discover and share. And there's sounds and LEDs and more, so I think that'd be a neat thing to do.
What I like about IR also is that it's a communication method that you don't need to ever worry about like FCC certification or TELEC or IC. It's like, and don't get me wrong, I love radio, I love Bluetooth, but if you want something to be used anywhere, you never really have to worry about IR. It's just like, you can just do whatever you want. That part of the spectrum, you're free to go. So I like that.
I've been checking CNN lately to see if the FCC is going to ban IR and sunshine.
The nanometer range.
Yeah, Friendship's out loud.
And also, there's a lot of toys that use IR. Like, we were watching that video about hacking what's the Star Wars toy, the robot. Oh man, the round one.
Yeah, the little round one.
I can't remember.
The new cute R2D2 that's
I know.
more monetized.
The round R2D2.
BBO or something like that.
BBDO? No.
Yeah.
Wine Kenny?
BB-8.
BB-8. That's right. I was like, it's something cute.
Bell Biv DeVoe. Now you know.
So that uses that toy uses an IR remote, right? It's remote control, but it doesn't use RF. It uses IR, which I think is kind of neat. Okay, so I set it up now so that it blinks the LED whenever it receives an IR signal. So that can make testing a little easier because I can be a little farther. So do you want to maybe hold this and we can do target practice? We can see how far I can be.
Yeah, sure.
All right, do you want to hold it up on over there, or how do you want to do this?
I don't know, hand me something.
Here, how about you take this?
Yeah,
you're a better shot than me.
Okay.
So I'm gonna hold this.
What do we press on this?
You press any button.
Any button?
Any button, and try to hit this from as far away as possible.
Okay, why don't you put it underneath the overhead so the folks can see it?
Okay, I'm working on it. Okay, there you go.
I got it.
Okay. So, but then how far away can you be? See if you can get it from across.
We have a tiny New York City apartment. I can't get too much further.
I know. Oh my goodness. You're really good at this. Okay, so you can actually be, if you're not...
I ran out of apartment.
So that's what, 12 feet?
Yeah.
How about you want to try the TV remote?
Not really.
No, because we'll have to turn on the TV remote.
No, I'll get a phaser later. More
Yeah.
on that soon.
All right. So it's hard to do it to yourself, but this does receive with this little remote from, 10, 12, 15 feet away. So that's pretty good. So it just turns out I'm really clumsy. But, so that's really good. So you can use it, and of course this is like a really small remote. If you're using like a TV remote, they often have like 3 or 4 LEDs. So you will be able to like bounce light off of a ceiling and stuff. So
Yeah.
the next step is
Tom pointed out that I was in fact the 1998 IR long distance hacking champion.
It's true.
Yeah.
I bet if I look at a copy of 2600, you'll be in there.
Yeah.
As the IR remote champion. Okay, so that's really good.
Yeah. Little side note, when Lady Ada and I were testing the TV Be Gone project, so a little quick history, I introduced Lady Ada to Mitch Altman like 6 years ago now. We were all in San Francisco, and I said, hey, Mitch, you have the TV Be Gone. Wouldn't it be cool to do an open source kit? And, he had a commercial product, but he went for it. And that risk really unlocked his journey into traveling around the world and showing and sharing projects and teaching people. But we started testing some of the TV Be Gones and some of the high power ones, and we were walking around in New York City. And in New York City, there was all these flat screen TVs that at the time American Apparel had like really crappy ads with like, I don't know, it was just, the guy got in trouble for like taking photos of underage girls. So that was back when they were on top. So we would be able to, from across the street or like a full city block, totally take one of those out.
Yeah, those were sweet.
As far as I know, it wasn't a crime. I mean, not
Another thing
not at the time it was.
that uses IR is cameras. If you want to do like remote actuation or like time lapses, another use for IR. So far so good. So if you can aim, you can hit this from 15 feet away. So that's the receiver. So maybe tomorrow I'll get the transmitter working. I also want to update I have like a kind of a crummy IR library I wrote a while ago. It's blocking, but it works pretty well. I think it does like NEC remote stuff as well. And if people are interested in learning more about IR receivers, can you go to my compy? And I'll give people links.
Yeah. I'm embarrassing myself with some old links and stories. Cool. Yeah, I know.
So this is the IR receiver that we have in the shop. It's a pretty good one. Another way here. Sorry, another way. And then we have a really good tutorial, which says like IR sensor. This tutorial here. We actually have a couple. We have one for like using it with Raspberry Pi. We have one for using with Gemma, and then like we use IR remotes and a bunch of stuff. wrote this one? Oh, this is Chris Young's tutorial. So this is a tutorial he wrote about his IR Lib 1. And you can use it with a yarn. And like people like to use it with projects where it's like, oh, I don't have access to it. Like for example, the Supernova Poi, we used it because it's like they're encased in a glass tube, and they're hard. Like it's hard to press a button, so you just use an IR receiver. But the IR sensor tutorial has a lot of details on how to use IR sensors and like, you know, I have a demo project like making an intervalometer. I actually made this intervalometer to help me take photos. So this is an example of how to use it. And it's designed, you know, I have a code about like example code and like how to use it with the NEC remote. That's pretty good. That's pretty much it. Not
Get out of here. It's like
not too much.
it's late.
Yeah.
Okay. So that's it, Disc of Lady Ada?
Yeah.
All right, so we'll probably do a broadcast tomorrow. We got some stuff coming up next week. Hey, thank you everybody out there. It's been an epic week. Hard day's night. I read this quote. I was telling you about this.
Uh-huh.
Mother Teresa just drops some great, awesome knowledge bombs once in a while.
Yeah.
So I got, you know, I read all these quotes because I'm always trying to think of like what things can make me a better person, or what stories are out there that you can tell others, and maybe they'll think about things. So her quote was, "If you can't feed 100 people, feed just one." And I was kind of in a punchy mood, and I thought, you know, maybe if you can't stop 100 bad people, maybe you can stop one. So, you know, if you don't stand for something, you fall for anything. And special thanks to the community out there over the last week who really rallied, and I think things are going to get better in the world of open source hardware. So thank you so much. Very much appreciate it.
It's all about the community.
Yeah. All right.
I mean, like, people have written some amazing open source IR libraries.
I
mean, isn't that cool?
Super shout out to Chris Young.
Yeah, like Chris Young, he wrote this library, and I just was like,
Yeah.
well, maybe I'll just try it in Circuit Playground, and
Yeah.
it just worked. And I'm like, that's so cool.
Yeah. Chris makes me want to be a better person every day.
Yeah.
Okay.
It's a trick, though, you know, it's because he wants me to make the Circuit Playground with IR built in, so it's like, aha.
Yeah.
I'll do some hardware, he does some code, meet somewhere in the middle.
It's like skateboarding. We're all just doing our tricks.
Okay. So tune in tomorrow unless something exciting happens. I will show IR transmission, and then maybe we'll build that project you want where it records a signal and then replays it back, and we can make that OWL project.
Okay. All right. Thank you, everybody.
Good night.
Good night. Good luck.